Hi everyone, welcome to the series Quant Revision for Cat. Let's start Algebra. In Algebra, today we are going to discuss logarithms. Logarithms, as far as Cat is concerned, you have 10 formulae for logarithms. As far as Cat is concerned, you have 10 formulae about logarithms. So let's start. The very first one is a power x equals to y. That implies x equals to log y to the base a. Here we have a condition of y greater than 0, a greater than 0, and a is not equal to 1. So it is the most important condition which you have to remember. In questions, it will be asked, find the number of values for which y this equation is satisfied. In that, you will find a solution, but after finding the solution, you have to check this condition. It is applicable for almost every question in logarithms. And second formula, which is log of pq base a equals to log of p to the base a plus log of q to the base a. If it's p by q, then here we'll get minus. Okay. And another important formula is log of a to the base b equals to 1 by log of b to the base a. Okay. And here you have to remember another one also, which is okay. The next formula is log of y to the base a equals to log of y to the base k by log of a to the base k. Okay. And fifth formula is log of a power p by b power q equals to p by q log of a base b. Okay. After that, sixth formula is a power log b base c equals to b power log a base c. I'll give an example for this. 32 power log 4 to the base 2 equals to 4 power log 32 base 2. So if you can solve this LHS, that is 32 power 2 equals to, which is 2 power 5 whole power 2, which is 2 power 10. Okay. So here 4 is 2 square and log of 32. 32 is 2 power 5. So this is why, which gives 2 power 10. Okay. So both are equal, right? And the next formula is it's the most important thing. A power f of x is greater than a power, suppose a power f of x is greater than a power g of x, and it is given that a is greater than 0 and a is not equals to 1. Okay. So if a is greater than 1, then f of x is greater than g of x. If a is less than 1, so 0 less than f of x is less than g of x. And you can similarly uh, remember another formula, log of f of x to the base a is greater than log of g of x to the base a. So here if a is greater than 1, then f of x is greater than g of x is greater than 0. Okay. So if 0 less than a less than 1, 0 less than f of x less than g of x. Okay, you don't have to remember this, but you can simply take an example and you can do it. Like if you consider 2 power 4 is greater than 2 power 4, 5, right? So here 4 is f of x, sorry, 2 power 4 is less than 2 power 5. Here 4 is f of x and 5 is g of x, which is 4 is less than 5. Since a is greater than 1, this thing followed. Okay, what if instead of 2, you are taking 1 by 2? Instead of 2, you are taking 1 by 2, which is less than 1. So you'll get this. You don't have to remember this. You can take a simply take an example and you can simply solve it then. And the next important formula, which is digits count. It is one of the most important formula, which is digit count. Okay. Before that, you have to remember one thing. Log of 2 to the base 10 equals to 0.301. 0.301. Log of 3 to the base 10 equals to 0.4771. Okay. So to find the number of digits, you can simply find the logarithm of that value to the base 10. If you are getting something like 2 point something, like 2.0102, it can be anything, 2 point something. That means it is a 3-digit number. Okay. So here we are adding 1. In case we are getting it is an integer, like we exactly got it as 2, then it is a 2-digit number. And if you observe that log of x base 10 equals to 2, that means x equals to 10 square, which is 100. Okay. So for 100, the value is 2. For 1000, the value will be 3. For 10,000, the value will be 4, and so on. Okay. So if we are finding logarithm value of any number which is between 100 and 1000, like suppose it can be 101 also, even for 101, we will get the logarithm value as 2.00 something. We'll get the value of which is greater than 2 but less than 3. So that's why we are adding one more digit to it, and we are concluding that it is a 3-digit number. So if we are getting exactly an integer, which means it is a three. We are here also we are going to add 1, but it is exactly a multiple of 10. Okay. So if you are getting 2, that means the number is 100. If you are getting 3, that means the number is 1000. If you are getting 4, that means the number is 10,000. Okay. After that, we have another important concept, which is number of zeros between decimal and first non-zero digit. Okay. So let us take an example of let x equals to 10 power minus 6, which is 0.000001. Here number of zeros are 5, right? Okay. Here also we are following the same method as previously. We will find the log of x to the base 10. Here we got minus 6 and it is an integer. Okay, that means integer means it is a equivalent to 10 power minus 6. So for 6 minus 6 we have 5 no, 5 number of zeros between decimal and first non-zero digit. Okay, so if you are getting log of x to the base 10 equals to minus 5 point something, that means we are having 5 zeros. Okay, we are having 5 zeros between first non-zero digit and the decimal. So even this also you don't have to remember. If you take an example like 10 power minus 6, if you are getting an integer, you have to subtract 1. If you are getting value like which is not an integer, it's like minus 5 point something, that means there are five zeros. Okay, so that's about today's class. In the next video I will start linear equations and quadratic equations. Thank you.